So your home plate is only 8 problems, and once again, that's only for review. We're still on expressions. Today we're going to finish up with some of this practice, and I'm going to touch up on a couple more things in class, and you'll see that in a little bit. But let's get started. Our objective for today, I can simplify algebraic expressions. Once again, I can simplify algebraic expressions. Tell your neighbor the main concept or idea for the lesson. Yeah, some of you read the objective again. No, the main idea is what? Algebraic expressions. And what are we doing? We're simplifying. We're done with the other stuff, okay? All right, quick recap from yesterday. We said that expressions, we cannot solve expressions. Is that correct? What can we do with those? We can only do 3 things. Translate, evaluate, and simplify. Are we there so far? Because today's the last day for expressions. Tomorrow we're moving on to equations. Yeah, let's go from the quarter. So, let's see how you do with your memory. Let's see. Yesterday I gave you a quick intro to Algebra 2 and connected all of the process or the concepts as we're going towards the new numbers. Is that correct? All right, turn your Cornell notes over to the back. I want you to copy that table. All right, copy the table and see if you can fill it out as much as you can. See how much you recall from yesterday's introduction. I'll give you some time for that. Ready, go. I forgot to mention for some of you that are struggling with recalling stuff, that you need more focus, drink some juice, like any kind of juice. Yeah, any kind of, because it's made from concentrate. Please. Yeah. So if you did it backwards on the real numbers, rational first, rational second, that's fine as long as you keep the numbers that correspond to each one. So that's the actual table. Yep, copy what you didn't have, and then we're going to go over a complex number. Give you some time for that. All right, so with that said, now we have this table full and your notes, and the only thing that I left blank was complex numbers, and I left it like that on purpose to have us recap in regards to what makes a complex number. So here goes again. A complex number is made up of real numbers, a real number, and an imaginary. Look at that. Aww. So if that's true, think about it. Get a real number, add or subtract an imaginary number, and you make up a complex. Let's see. Write something down and see if you're understanding what we're talking about. And then from there, Damien's going to help us out, enlighten us with an example. Nice. All right, Damien, start us off with a real number. Give me a real number. Just 23. Very good. Plus, has someone? Can you give me an imaginary number? 4i. Hands if you agree that's a complex number. That is correct. So, for those of you that forgot, this becomes 4i because the square root of 16 is 4, and we're left with a square root of -1, which is I. Remember those? Square root of -81, everyone, what's this imaginary? 9i, and so on and so forth. So write me another imaginary number, a different one than that, and then share it with your neighbor so they can copy it, please. All right, so going back now to our presentation. So now that we know what complex numbers look like, they come from real numbers and imaginary numbers. So everybody up to right there, we're good, right? All right, so quick recap in regards to the properties for getting started with expressions. I covered the additive inverse property. There are the examples. Everybody see them? Okay, tell your neighbor in your own words a definition for that property, please. Say definition for that property. Okay, we good? I heard a number plus its opposite is 0. Yes, something like that? Yeah, we got that? And then we go to the identity property of addition. Look at that. And in your own words, tell your neighbor what would be a definition for that. Okay. So it looks like we're on the ball, yeah? Okay. Next. From there, I went and did a quick intro to numerical expressions, but since we're no longer in numerical expressions, we're moving on to what? Algebraic. So turn your Cornell notes over to the back, and in your fair model, write algebraic expressions. Without looking at your notes, I want you to write a definition for algebraic expressions, one example, one non-example, and a hashtag for critical attributes. I'll give you some time for that. Let's see if it looks something like this. Pretty good, right? Pretty close? So, somewhere in your definition, it should have expressions with variables, numbers, and operations. Something that's simple. That's fine. And at least one example for the examples, one for the non-examples, and a hashtag. All right? All right, let's move on. So, from there, we're going to get started with where we left off yesterday. And underneath your fair model, I want you to write example Q. Let's write simplify. And right now I'm going to start with numerical expressions, and then I'm going to touch up on a couple of things, and then we're going to move on to algebraic. But let me finish this. Okay, let's start slow, yeah? -1 plus 5 plus -6. All right, so yesterday we did something like this. Is there another negative? Yes, right here, so that's -7. Bring down the +5. 5 of these cancel 5 of those, so we're left with -2. And have you got that? Okay, good. Let's go to the next one. Let's do 3 plus -2 plus 1 plus -3. All right. From there, yesterday I said whenever you can see and identify any zero pairs. Is that correct? Do we have any zero pairs? Yes, right here and right here. That leaves us with -2 and 1, so -1. And have you got that? Okay, good. So far so good, yes? All right, let's crank it up a notch. Let's go -5 plus 3 plus -2 plus 7 plus -1 plus 5. Okay? All right. Do we we have any zero pairs? Yes, the first one, I think we can do this one with this one, yes? The second one that is not as obvious will be this one with this one, and we're left with 7. Hands, have you got that? Okay, good. All right, so now that we're done with addition, I want us to touch up on subtraction. Subtraction. And this is where it gets a little, foggy for some of you. And we're still We're still simplifying. Okay? So, for those of you that were with me in the past, you're going to remember that I introduced it by doing 5 minus 7. And I said, okay, guys, we've been doing addition all along, and it seems by the time that we got to here, it seems easier now. Yes? Yes, Mr. Q. All right. But then all of a sudden, now we have negatives, and then we're going to involve negative numbers with subtractions. So to make it easier for the eye, I said we're going to use the additive inverse property to change this to addition. Here it goes. Look up, please. And whenever I see a subtraction, the additive inverse property says, listen to the key terms, additive, inverse. What does additive imply? That means we're going to change this to addition. Inverse means that the second number we do the opposite. What is the inverse of 7? Negative 7. I bring down the first one as is. Now I rewrote this. Is this easier? Yes. Negative 2. Copy that, please. That's using, again, the additive inverse property just for 2 terms. And once again, first one stays the same. This goes to positive, and this is the opposite for the inverse. Opposite. All right. You do one. Here we go. 12 minus 15. Rewrite it. Simplify it. And now, the reason I'm having you go back the steps again, because some of us are already there, and we don't need to do this anymore. In our noodle, we had plenty of practice back then, but some of us really need to reconnect with it. So here we go. This is 12 plus negative 15, and this is negative 3. Yes? Okay, show me with fingers, 1 being the lowest, 5 being the highest. How comfortable you are with these so far? Okay? All right. So now that we have that, let's crank it up a notch, yes? Let's go. Example, mega Q. Here we go. Let's do 3 minus 6 plus 5. Okay, go. All right, so this is what you should be doing in your noodle. Are there any subtraction signs? Yes, right here. This is this. The opposite of that one is negative 6. So I no longer use this one. So what do I have left? 3 and 5, that is 8. So this is 2. Hands, have you got that? Okay, good. Next, do another. Negative 7 plus 3 minus negative 2. Putting you a little curveball here, see if you pick it up. All right, now check this out. Some of you might have said, oh, this is a subtraction, I'm going to change it. No, there is no number here. This stays as a what? A negative. The subtraction is right here. So this becomes addition. The opposite of this is 2. So therefore, 2 plus 3 is 5. And negative 7, that is negative 2. And have you got that? Okay. All right. crank it up a notch, yeah? All right, here we go. Let's do negative 1 minus negative 9 plus 3 minus 6 minus negative 2 plus 1 minus 3. And I'll stop there. All right, let's see. Subtraction, this becomes addition. This becomes a positive 9. Another subtraction right here. This becomes addition. The opposite of this is what? Negative 6. Addition. This becomes positive 2. And another addition here, and this becomes what? Negative 3. All right. Do we have any zero pairs? 3 and negative 3. What else? 1 and negative 1. Anything else? No. What is 9 plus 2? 11 plus negative 6. So the simplification is 5. And we got that. Okay. We got this, yes? All right. Next. I want to revisit your favorite. Here he goes. Order of operations. And yes, you guys remember the acronym, right? Please excuse my dog, Aguasaco. There it is. I had a dog, and my I still remember, I was raised in the South Mexico, and we got a dog, and my grandfather's off. Okay, so what do you want to name the dog? I'm all like, Husky, because he looked like a wolf. And he's on, no, he's too short for that. I'm like, okay, then you name him. He's on, name him Aguasaco. I'm like, what? It's 2 words in one, which means like water toad. I'm like, it doesn't make sense. But I didn't want to like tell him because, out of respect, it's, my grandpa. So I said, all right, fine. So it stayed Aguasaco. That was my dog. Anyway. So here's the key with order of operations. We first check for parentheses or grouping symbols, and then we go to exponents. Those two things we do a first check throughout the expression. The second thing we go to is multiplication and division. But this is where some of you make a mistake. Some of you go straight to multiplication and forget that whenever there's these two operations in the expression, we always read the expression again from left to right, whichever comes first. Not necessarily multiplication, because sometimes guess what comes first? Division. So therefore you need to do the one that comes first. And lastly, when you get to addition and subtraction, the same thing. You scan your expression from left to right and make sure you do the one that comes first out of those two. All right? Example, super duper cute. Here we go. Let's do 10 divided by 5 times 2 plus 1. Simplify that using the order of operations. So. All right, should be almost done. Now check this out. Possible answers. Some of you got 2, and some of you got 5. Let's find out which one's correct. Do we have parentheses or exponents? No. Do we have multiplication and division? But we start from where? Left to right, whichever comes first. So what is 10 divided by 5? What is 2 times 2? What is 4 plus 1? You see what I'm saying? Not necessarily do you have to start with multiplication, because if you start with multiplication, look up, here goes the mistake. What is 5 times 2? And 10 divided by 10 is 1. 1 plus 1 is 2, and that is incorrect. So be careful. Okay? One last one of these. All right, here we go. Let's do 5 squared plus 16 divided by 4 times 2 plus 3, open parentheses, be nice, 6 minus what? 1. All right? See how you do with that one. Go. All right. Who did we call on? Oh, Karina, what'd you get? Okay. Help her out. Let's pick someone from the other side. How about Carlos? 41. Hands, have you got that? Close. Well, no, not close. The other? 48. Hands, have you got that? Oh, let's check. Parentheses. What is 6 minus 1? 5. Okay, we'll leave that for right now like that. Exponents. Yes, this is 25. All right. Multiplication and division. Do we have any? Yes. We're going from left to right. So this is 4 times 2. That is 8. So we're done from here all the way to here. Yes? So I bring down the plus. And then multiplication, 3 times 5 is 15. Bring down the 25. So let's see. 25 plus 15, that's 40, plus 8, that's 48. Hands, if you got that? That is correct. Yes? What's that? Yeah, it'll give you the same thing. Yeah. All right. So I just wanted to touch bases with order of operations before I moved on. So since we're done with that, let's move on and crank it up a notch. Yes? All right, here we go. Before I do so, though, lock your toolbar. Send me a picture of your work so far. All right. So now that we're done with all of that, let's get into algebraic expressions. This is our last part, and today we're going to be moving on after this. So I want you to write example. Oh, you already did super Q, right? Let's do example Shazam Q. And we are on algebraic expressions. And what are we doing with those? We're still simplifying. All right. Once again, I'm going to start slow and I'm going to increase. Okay? I'm going to start with just positives first, adding. From there, I'm going to switch it up with subtraction and addition. From there, I'm going to continue adding more variables. So let's see how your noodle goes. Okay? Here we go. 4x plus 2 plus negative 7x plus negative 1. All right. So for those of you that already have your colored pens, this is a good time to start using them, because once I give you more variables, you need more organization. So I usually start with making a box in blue. And is there another X? Yes. All right. And we know that the variables are only a label to tell us that they're the same kind. So that means both of them are X's. We focus on the coefficient. What is 4 and negative 7? Negative 3. And next, the constants. 2 plus negative 1, that leaves me with positive 1. Hands, if you got that. And remember, try to keep the variables first, the constants at the end. Okay, let's do another one. Here we go. Let's do 3y minus negative 2 plus y plus 3, and let's do plus negative 6y. Okay, first things first, do we have addition all the way through? Do we have addition all the way through? No, there's a subtraction, so what are we going to do? Additive inverse, right? This becomes this, and this becomes a positive 2. All right, so now I can start. 3y plus y, that's 4y, minus 6y, that gives me negative 2y. The constants, 2 plus 3, that's positive 5. All right, show me your fingers how comfortable you are with these so far. Okay, good. All right, so we'll go with that, yes? All right, let's crank it up a notch. Here we go. Example MJQ. Here we go. 3x to the second plus negative 3y plus 5 plus 2x plus negative 2x squared plus 4y plus 1. Nice. All right. Here we go. So I'm going to start by boxing my 3x squared. Is there another term with x squared? Yes. So I write x squared. What is 3 and negative 2? Positive, right? Positive 1x squared. Okay, so there it is. Positive 1x squared. All right, next. I got negative 3y, and I got 4y. That gives me positive 1y. All right, next. Do we have an x? Yes. So I just bring that down to x. And then we got 5 and 1, that's 6. And if you got something like that. Or x squared plus 2x plus y plus 6. Hands if you got that. All right. All right, log out, please. And, yeah, next person in line, I guess whoever is next on taking the iPad. And once again, your home plate, you already copied that earlier. Home plate is 8 problems. Good one, guys. See you guys tomorrow. Bye.